The third question is to describe the components of the alveolar gas equation and how it impacts oxygen availability, and to provide an example at sea level and altitude. There are a lot of components to this equation, including the partial pressure in the alveoli, the partial pressure of oxygen, and the respiratory exchange ratio. But at sea level, the partial pressure of oxygen in the alveoli is relatively high, which allows for a more efficient oxygen diffusion into the blood. And at high altitudes, the atmospheric pressure decreases, which reduces the partial pressure of oxygen and therefore reduces the partial pressure of oxygen in the alveoli, which makes oxygen uptake less efficient. This is why hyperventilation is common at altitude, because it lowers the partial pressure of carbon dioxide in the alveoli, which raises the partial pressure of oxygen in the alveoli as a compensation. And then I can do some examples of that. So I have the equation written right here. To find the partial pressure of oxygen, we need to subtract the barometric pressure, which at sea level is 760 minus 47 for humidification, and then multiply it by the percent of oxygen, which is 2.1. So we end up with 149, and then we can start plugging things into our equation. So we have 149 minus 40 divided by 0.8 plus 40 times 0.21 times 1 minus the respiratory exchange ratio, which is 0.8, divided by respiratory exchange ratio, which is 0.8. And then we'll end up with 149 minus 50 plus 2.09, which is 101 millimeters of mercury. And this is for at sea level. And then for an example at altitude, we need to do the same thing. So at 18,000 feet, the barometric pressure is 380. Subtract that by 47 for humidification and multiply by 0.21, and we end up with 73. And then you can plug that into the equation. We're gonna do an example of hyperventilation. So the carbon dioxide will have decreased to 29, 0.8 for respiratory exchange ratio. And then we end up with 38 millimeters of mercury, which is significantly lower than at sea level, but this is also at 18,000 feet. And if we did this equation and we didn't include hyperventilation, this would be a lot lower, about 50% lower. So it is, hyperventilation is a good compensation for altitude, and it helps increase that alveolar partial pressure.